I want us to find all the zeros of this polynomial function. The first thing we want to do is see if we can factor. But I look at this polynomial, it has 5 terms, and we cannot factor this. So the first thing we need to determine is our possible rational zeros. And to do that, we will use our P over our Q. P is 8. Your factors of 8 are 1 and 8, 2 and 4. So we can know that our factors of P would be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Q is your leading coefficient, 1. So your factors of 1 would be 1. So we need to place every P over every Q. Well, 1 over 1 gives you 1, 2 over 1 gives you 2, 4 over 1 gives you 4, and 8 over 1 gives you 8. So these are my possible rational zeros. Now, normally to find the remaining, or to find the real zeros, we would start plugging these numbers in one at a time into synthetic division. But since we've talked about Descartes' rule, I want us to use Descartes' rule to determine the number of possible positive zeros. So we do that by looking at the number of sign changes of the original f of x. So let's count the sign changes. From positive to negatives, 1. Negative to positives, 2. Positive to negatives, 3. And negative to negative, there is no sign change. So we're going to have 3 possible positive zeros, or we must say 3 minus 2 gives you 1. We could either have 3 positive or 1 positive. Next, let's determine the number of possible negative zeros. And to do that, we will have to find f of negative x. So we'll have to take the original problem and replace every x with negative x. So negative x to the 4th minus negative x cubed plus 2 times negative x squared minus 4 times negative x minus 8. So replace every x in the original problem with negative x. Well, negative x to an even power, that's multiplying 4 negatives. A negative times a negative is a positive, positive times a negative is a negative, and a negative times that 4th negative gives you a positive x to the 4th. Any negative raised to an even power is going to give you a positive. Now here we have a negative x raised to the 3rd power. Well, a negative times a negative times a negative gives me negative x cubed, times that negative, though, gives me positive x cubed. Negative x squared is positive x squared. Times 2 would give you 2x squared. Negative 4 times negative x is positive 4. X minus 8. So here's my polynomial that I have, x to the 4th plus x cubed plus 2x squared plus 4x minus 8. So how many sign changes do I have here? Positive to positive, no sign change. Positive to positive, no sign change. Positive to positive, no sign change. But positive to negative, there's 1 sign change. So the number of possible negative zeros is 1. So we do stand a better chance of getting a positive 0 than a negative. So since I have a larger number here, I'm going to start with using a positive 1. I'm going to try my positives first. So what I want to do is put 1 in the box, and I will pull down my coefficients from the original problem and use synthetic division. Check descending order. I have a x to the 4th, a 3, a 2, a 1, and a constant. So I'm in descending order, and I'm not missing any terms. So let's pull down those coefficients. 1, negative 1, 2, negative 4, and negative 8. So let's use synthetic division to determine if 1 is a real 0. So remember our steps on synthetic division. We multiply and we add. So we pull down 1. 1 times 1 gives you 1. Add, we get 0. 1 times 0 is 0. Add, you get 2. 1 times 2 is 2. Add, we get negative 2. 1 times negative 2 gives me negative 2. Add, we get negative 10. Unless we get a remainder of 0, the number is not a real 0. So 1 is not a real 0. Next, let's try 2. Going back and using those same numbers that we pulled down from the original f of x, let's see if 2 is a 0. So, using synthetic division again, pull down 1. 2 times 1 is 2, add, we get 1. 2 times 1 is 2, add, we get 4. 2 times 4 is 8, add, we get positive 4. 2 times 4 is 8, add, we get 0. So, yes, 2 is a 0. So, remember that if this was x to the 4th, we lower this down 1, it would be x cubed plus x squared plus 4x plus 4. Now, we have a 4-term polynomial. I'm going to try to factor this. Now, if I can't factor this, I will try 2 again with these numbers. Before I go back to my list of numbers and try 4, I will try 2 again to always see if this is a double root. But I'm going to try to factor this since I have a 4-term polynomial and I could possibly factor this 4-term polynomial. So let's try it here. I see that these first two I can take out x squared. If I take out x squared, I go through and divide the first and the second term through by x squared, leaving x plus 1. Looking at the last two, I see I can take out a positive 4. Go through and divide each one by positive 4, gives me x plus 1. My parentheses are the same, so when your parentheses are the same, write down x plus 1. That's kind of like, that's your GCF now. If you go through and divide each one by x plus 1, the x plus 1's cancel, leaving x squared plus 4. Recall that in factoring by grouping, the two GCFs that you take out in the very beginning will always form that second binomial. Now we need to set each one of these equal to 0 to find the real zeros. We take x plus 1, set it equal to 0, and x squared plus 4 equals to 0. So subtract 1 from both sides. I get x equals to negative 1. Here, subtract 4 from both sides. I get x squared equals to negative 4. To go from something squared to something not, take the square root of both sides. So I'm going to come up here and get x is equal to plus or minus the square root of negative 4. Well, we know that we have to take out the square root of a negative immediately. That comes out as I, and the square root of 4 is 2. So there's my two roots. Excuse me. So I found 2 to be a root. So I'm going to put my answers here. I found 2 to be a root because I got a remainder of 0. Then I factored. I found x to also equal to negative 1. And then I set x squared plus 4 equal to 0. And I found my two remaining roots to be positive 2i and negative 2i. So my first two were my rational zeros. They came from our list of possible rational zeros. But the last two were my irrational zeros. So there's all 4 of our zeros. Remember, our highest exponent in the original problem was x to the 4th. Therefore, I had 4 zeros. And that would be my final answer. Positive 2, negative 1, positive 2i, and negative 2i.